Good morning, everyone. My name is Khalid Mosalam. I am the director of PEER, and I would like to welcome you all. We almost have a full house. I think some other people will come a little bit later. So we have 2 days planned for you. They are not full days because we designed them this way. So we have a lot of discussions. So we have lots of minutes of discussion, and it's intended this way. So this is unlike our annual meeting. It's not a presentation after presentation, or so we don't have keynote lectures. It's supposed to be short presentations and lots of discussions. So I'll talk about that. So I just have a few remarks. Some of them are related to what we're doing in these 2 days. Some of them are just to give you a glimpse of what we do in PEER these days, what has happened in the past year, and a few other comments. So hopefully I won't take more than 20 minutes. You told me I can use more, but I'll try to stay with 20 minutes. Last time we met was in the annual meeting. It was a great event and not too far from here. The theme was the PEER at 21. We're still at 21. We're still in 2018. And the theme was the practice of performance-based earthquake or performance-based engineering for natural hazards. The first announcement is the 2019 annual meeting is under planning. The theme is obvious. It will be the 25th anniversary of Northridge. And we have been talking to our colleagues in UC Irvine and UCLA to co-plan this event. So it will be held somewhere in LA, most probably UCLA or maybe UC Irvine. So we haven't decided on we decided on the city, but not exactly where in the city. Hopefully we will know soon. It will be a good time to reflect upon what we have learned in the past 25 years from the Northridge event. So stay tuned for more announcements about this. To remind ourselves what's PEER. PEER is all of you, and we have many active institutions. We're delighted to have University of Nevada, Reno now joining our 11 core institutes and several other affiliates that are active. The theme of activities within PEER are still integrated performance-based engineering, specifically performance-based earthquake engineering. You have seen this slide many, many times. So that's still really the brilliance of those who started PEER. That slide is a testimony of their brilliance because we still keep showing it, and it's always fitting the times we are in and the research we do, because it's a very good vision that can last for several years of how you break down the problem to different disciplines and different areas, and the connectivity of these can have a nice mathematical equation, but also have nice graphics associated with it. So in addition to that expansion in US, we also have activities that are more worldwide. We used to be a member of the board of directors of GADRI, the Global Alliance of Disaster Research Institutes. Now PEER serve on the advisory board. The mission of this very large coalition of institutes, which now have reached about 150 of them, is to combine technology and multi-hazard expertise of multiple institutes, have reached, as I said, about 150 across continents for interdisciplinary approach to reduce global disaster risk and increase resiliency. So many of the words that we hear in all our meetings these days, but really engagement in GADRI have been very useful in seeing what other areas of natural hazard, what is the language they use, not just Japanese versus English, but it's the language that's used in different hazard domains can be really different, and and can be confusing at some point. If you want to learn more about the Gadri activities, a little bit of peer involvement in it, there was a paper that came out that summarized the third Global Summit of Research Institute for Disaster Risk Reduction. So that's available in the web, and you can read more if you want to be engaged in one way or the other with these many institutes. In peer, we're still active in our analytical simulation. Frank walked in a little time ago. So the activities in OpenSeas on Bridge PBEE, which is fitting to this meeting because this meeting is mostly about the transportation system program. Activities in hybrid simulation, we're still doing quite a bit of work on that. I saw Gilberto a while ago, so we're still active in that sense. Recently we had some several forms of interaction with MTS to continue development of OpenFresco. Databases is still our backbone of really doing research, the NGA cohort of activities. SPD can use a little more work, not much have happened for a while now. SPO, this seismic performance observatory, lots of activities related to that database. I will say a few things about that at the end. We have been really interested in doing more and more of these blind predictions. Last year, it was a successful event. It highlighted some good things and mostly some deficiencies in how we do simulations. 19 teams have participated in this exercise. They used a variety of nonlinear analysis software. OpenSeas by far was the one that's mostly used. It doesn't mean it was the one that won the competition, but definitely the spread use of it is indication of how the community embraced this platform, and naturally we need to continue working in developing things and understanding why certain things weren't predicted well and so on. So that motivates us to make use of all these facilities. Last year, blind prediction was mainly an effort between UC San Diego and UC Berkeley in terms of testing facilities, first-class testing facilities all over the 11 campuses can really benefit the community from more designed blind prediction. So stay tuned for an upcoming one. It's an effort between UNR and UCSD. It's more focused on geotechnical aspects. So we are not only my background is structural engineering, but we have to balance all the expertise within peer and the interest in a variety of topics. So we are in the planning phase of releasing that. So hopefully that will be also another successful event. As I mentioned, there is quite a bit of activities related to workshops, and we would like to do more of this. So this is just one example of a workshop we held in this room last March in collaboration with MTS, focused on hybrid simulation. Several of you may have great ideas of a workshop that's topic specific. Peer would be happy to facilitate that. It can be held here, it can be held in your own institution. We can help in advertising this and helping people to register and so on. I really would like to thank the peer staff of taking the effort on updating our website. Having a website that hasn't been updated for 15 years is not a good idea. And again, forgive us, this is done by really non-expert in web development. So it's done by our peer staff. and we do our best. Some links may be broken. Hopefully everything is fixed now. But it's really effort by Gabriel, Christina, and Erica, and Amarnath, and so we didn't hire a webmaster to do this. I just couldn't justify to myself paying $10,000 for someone to just develop a website. But it may have some things that you may not like. Let us know. We'll try to fix them. We'll try to improve them. We may have missed the important piece of information or important link or important event. We have so much stuff in Peer that goes back many, many years. So there may be something we missed. There may be a broken link. There may be a tab that needs to be included. Your feedback will be really important. But I have been checking, doing spot check here and there. So far, many things are working well. I haven't run into problems yet. Our reporting still going strong, but I have a request from you. This year, we haven't had many reports submitted yet. We encourage you, if you have a phenomenal PhD thesis or a master thesis that came out, you would like to publish it as peer report. We have very good editing, as you know, and we continue to support that. We reinitiated our peer annual reports. So far we have 2 reports. If you want to get more and more information about what has happened, all the events and so on, we switch a little bit from kind of end of the year report to like mid-year report that span 2 halves of 2 consecutive years. So we went like from 2016 peer report to 2017/2018 peer report. That works a little better in terms of timing, but being able to continue to produce a first-class report every month plus some is really phenomenal. I don't think any institution can do that. It's like having a department that produces a PhD thesis every month. That's a very good publication rate. So with your support, that will continue. One of the new areas are, I would say, relatively new, is to push more for data use, not just the data storage. So I showed this before just to give a summary of what we do in terms of data-driven structural health monitoring. So we have been doing some work related to that, some work related to vision-based structural health monitoring, a little bit on the sensor development. I'll show one example of that because it's related to the bridge activities that is funded by the Lifelines program from Caltrans. Development of the database of SPO, lots of activities related to that, such that it become the repository or the platform where lots of this data can be handled and manipulated. So the example I always show, if the west span of the Bay Bridge is instrumented and we can monitor all these instruments, we can actually have rapid reporting about the health of important signature structures as such. But it's not just doing the straightforward, or actually not exactly straightforward, but the conventional data processing and system identification, but maybe doing a little bit more of the supervised learning or unsupervised learning, trying to get more and more into the data science, at least data science terminology. I think that would be good for peer. Lots of interest in every campus on data science. And for us to try to dodge this and not take advantage of it is not in our best interest. We have lots of data that if you talk to computer scientists, they would really love to get this data. They would really love to get the domain expertise we have because they struggle with that. They know how to do things well in terms of data analytics and all this, but the domain expertise, they still haven't embraced that. And I think we can be really leaders in that regard. Sensors are becoming cheap and everywhere. How to capitalize on all this data, how to make use of it. I am sure the SIM Center is doing some work on that. I am sure other entities. I am not claiming PEER is inventing anything new here, but embracing it, I think, is something really important. I'll show one very simple example. It was an idea by Tom Chance that we thought would be great, is to try to develop a sensor that can measure bridge settlement on long term. So I'm not going to go into too much detail, but just to show you what we try to build is if you do a laser-based measurements, you have a laser emitter, you have a camera-based receiver, so you can take the crosshair of the laser and find out where it's XYZ, such that you can do this measurement. You can do that in a very cheap way by doing power control, that's a combination of Arduino and Raspberry Pi, such that you can control the power consumption. You can benefit from the data collection tools that you can put together, the visualization, doing a little bit of computer vision, manipulating the crosshair. You see a lot of ripples here of that laser crosshair. That's a very zoomed picture because we're using a very, very cheap laser with very, very lousy lens. So that's an artifact of the lens. But then if you just run a Sobel operator, which is a common operator to calculate gradient in computer vision, in the X and Y, fit some Gaussian distribution, get rid of the noise, even with such lousy measurements, you can bring down your accuracy to 2 pixels. It can't be better than this. So if you have a better camera, you can imagine what 2 pixels mean. In the case we have been working on, that brings your accuracy to 6/1000ths of an inch. And this is not a theoretical number because we actually ran a little experiment that's in the basement of Davis Hall, where you have your laser module, you have your camera module, you have a little rail that can change where is the camera is located, so you fake what settlement is, right? And you take your readings. We're trying now to build a little case for our sensor. We use a little bit of 3D printing, and results are very interesting. So here, this is actually a local server that we put together that sits in one of our machines. Data is collected. You do all the computer vision algorithm. So this is an example where we applied no change of the elevation of the camera. We applied 1500ths of an inch, applied a quarter of an inch. The data goes straight to the server, gets manipulated, and you see these steps indicate the actual location of the camera or actual location of the laser, which has to do with something moving with respect to the other and being able to capture it, getting a clean measurement such that it gives you almost a zero. Zero is a terrible number, and it's very hard to get zero in anything. So you always get a little bit below or a little bit above, but you get your 1500ths of an inch or quarter of an inch with no big deal. So that's one small activities we're working on, and thanks to Tom of being visionary to actually fund this as part of the Lifeline program. SPO is actually where most of our new data go in, whether it's data from instrumented buildings or data from images that I will talk about in a second. So Gabriel have been working hard to keep that alive and active. It has been used when a group from PEER went to Mexico, where they were able to upload images immediately to SPO. If the data analytics are working there, we could have been processing some of these images in real time. You may have seen several announcements about this PEER Hub ImageNet challenge that is out there. I am really impressed with how this is developed. That was a very simple idea we thought of because of SPO that Professor Steve Mahan has led its vision. And we said, well, if you have all these images, can we actually do a little bit of labeling of the images or annotation of the images? Then can people use these annotated images to do some classification of damage in as close to real time as we can? And then we start learning about what people do with images. Then we learn what Stanford have been doing for several years with ImageNet Challenge. They have been holding that since 2010. By the way, they stopped doing it this year, maybe because we started, I don't know. They are afraid of the competition or something. So 2018, they don't have ImageNet Challenge. I don't know the exact reason for that. So what will happen, or at least that's what we're thinking, is we're going to be holding this every year. We're going to be providing the competitors with a large number of labeled images. This year, probably it will be about 12,000 because we're doing this ourselves with a small group of people. If people are interested, you can apply now. The application is open. And I want to give you a little bit of important information. The competition will actually start in August 23rd. This is when we are going to provide the applicants with the labeled images, the 12,000 or more. At the moment, we have about 8,000. We're still working hard to get to the 12,000. Our initial target was 20, but it looked like 20 is getting harder. But once we open this for application, so far we have 30 teams. That's a total of 70 people have signed up. And this is within about 2 weeks. We still have we are not going to close the application period, so anybody can apply. So that's 70 people who have interest, and I thought in the beginning that would be mostly CS, stat type of people, but actually it's not. It's about 26 teams that are civil engineers who have interest in getting involved, and that also motivated us to really think of giving awards. So there will be an overall winner, and there will be a winner of each task. So the chances of people winning is really high. But what I'm impressed about is the fact within a week or two, we had 30 teams with a total of 70 people applying. And you look at their distribution, they are from everywhere. So it gives an indication we're really thinking in the right direction. There is interest out there. There is expertise out there that we may not be aware of. So if you go to the SPO website, you see also a little app that you can, in terms of uploading images, you can do that anytime. That's open. In terms of labeling images that are already on the database, you can do that anytime. The final labeling become a majority vote. So if one image gets labeled 100 times, that this is 99 of them, this is a sheer crack, one time this is a cat, probably it will be labeled as sheer crack, not a cat, you know. So I use cat and dog because that's what mostly ImageNet does. So again, why this is important, in every field there is a sort of an ImageNet now, in space, different events and so on. So we thought, well, we should have this fee ImageNet. And really the main reason is this. When they started ImageNet Challenge in 2010, they had 35 competitors. We are 30 and we haven't even closed the door. So we're getting close to that, and you see sometimes even it went below 19. And with the increase of the number of teams, the error in the prediction went significantly down. Starting with 28%, went down to 3%. So we hope that will help us in understanding how our structures perform, how our different components perform, which hopefully some clever people can take that information and improve our computational predictions. So ultimately, we will have different tasks that the competitors will be asked to predict. They vary in their level of difficulty. Some of them are just binary, which is easy to get. Some of them have multiple outcomes. And if eventually this become an app that you have in your cell phone, you take your image, gets uploaded to SPO, all the data analytics happen there, then you have a classification of the image you have taken. If you want to read a little more about this, there is a paper that came out that looked at a first generation of this effort. We collected, at the moment, 25,000 high-quality images. Not all of them are labeled. So far, we have about 8,000 of them labeled. We're hopeful that half of that, about 12,000, will be labeled before August 23rd, which will, when the time to release or start the competition. A little bit of background on that you can find in this paper, which is, again, available on the web. So now switching to the topic of this workshop. We're focusing on projects related to Transportation Systems Research Program, a little bit also from the Lifelines program. So these are the funding platforms that support all these projects that you will hear about. Just to remind you, last year we released our request for proposal. You may have read this document. Several people have formed the research committee at that time to craft this request for proposal, which is based on previous work. Again, we didn't reinvent the wheel here. We just took what others have developed and we added a few things here and there. So that was released in October 2017 and projects started in December. We ended up funding about 17 projects with about 5 or 6 funded by either TSR, the Lifelines, or continuation from previous years. So the research topics revolved around 5 or 6 major areas. Geotechnical engineer with several subtopics. Performance-based earthquake engineering of bridge and other transportation systems. Several areas of application. The methodology itself, which doesn't have to be specific to bridges, but it maybe use bridges as an example, and also several PBEE tools that people may be interested in developing, visualization and so on, like Bridge PBEE that Professor El Gamal is doing, for example. So that resulted in currently 24 active projects. I believe at least 22 of them are presented in this event, only 2 that have late starting, even some of them have very late start but still presented, like ET project just started, but we're happy that you are able to tell us what you are going to do. But some have started really late and they will not be presented, only 2. So we have also other projects funded by the Lifeline that will be presented, like the workshop that Sashi Punath has led. He will come later today. He just told me he will be here. Also, Professor Filippo's project funded by Lifeline will also be presented. So you have a single handout which has the program for the 2 days that give you the list of all the projects that will be presented. So I'm not going to go through the list, but the point I want to make is we have 16 presentations today. I urge the speakers to talk maybe for 15 minutes and then leave 5 minutes for direct Q&A for their this specific projects, mainly for clarification rather than discussion. And then after each session, we have between 25 and 30 minutes to discuss what is presented in each session. So we're going to have today a total of about 100 minutes of discussion, not including the breaks and the 5 minutes after each talk. Tomorrow we have even longer time for discussion, about 145 minutes. We put a adjourn time of 4:30. We can extend it to 5 if you are interested. We can shorten the 1:45 to 1:15, and you can leave half an hour early. It depends on how things will progress, but tomorrow we have only 12 presentations, and again, more time for discussion. In the back of this single handout, this is my last slide. We listed a few questions that we thought they would be useful for the presenters to be aware of, and mainly also for the discussion to try to answer these questions. Others, of course, may arise, but you get the idea that we want this not to be a set of projects that are disconnected. We would like them to be connected. We would like this to be a real program. So you are the best one who can tell us how your project fit in the TSRP program. Are there specific projects that your project can benefit from, can interact with, so you, within the 2 days. So that was the reason of avoiding breakout sessions and the geotechs talk to themselves and the structure talk to themselves, because there may be a lot of things to benefit by listening to your colleagues and seeing what they do. We're all busy, and taking advantage of these 2 days to see what others are doing will be really important. How can we initiate this interaction between these projects? So you may find something that really interests you. We may have a better mechanism than you just calling your colleague by putting this in the RFP in the next round, for example. So how to make this interaction really tangible and happening. Are there any areas of that potentially can enhance the program that we can include in the future request for proposal? Here, future is very near future. We're talking about next month, at the most early October, we're releasing the next request for proposal. We get the good news July 1st that we have our $1 million again. You know, every year we hold our breath that there's going to be a budget cut and we are not going to get the $1 million that we give in this RFP. So we had confirmation this year. We have our funding, and that's again, PEER is trying to reduce expenses as much as we can, such that this research funding is really used for research. So that's the whole idea. So a new RFP will be coming out soon. It may be exactly the same description or slightly different or dramatically different, we will see. Again, industry partners is very important. They have been supportive to PEER. Their membership and all that is very useful for our operational budget. And their engagement and their touch of reality of what really the industry need. There is only a handful or very few projects that engage industry partners. We would like to see more of that, and your thoughts, especially those couple of projects that have industry partners, will be very useful to hear from them. Lastly, which is probably the most important point, in PEER we would like to do things that individual investigators cannot do. That's the whole idea. We would like people to work together. We would like inter-campus activities. Of course, intra-campus activities also good, working with your direct colleagues, but working with colleagues between UNR and Stanford, I take this example because we have such a project, is a good thing. And it can really show the capability of the center. It justifies why we are who we are, why we have that many institutions, why campuses are not, all of us can be, each campus can be self-sufficient. We have outstanding geotech structures, data scientists, but there is something about working across campuses that has always been coined to PEER, and that's an important thing to keep and to motivate. So, and each campus, of course, has their own strength. If you want to do stuff that involve water, you always have to think of Oregon, because they have the best facility there. If you want to do centrifuge, you just straight, you're going to think of Davis. But you may have a great idea that can use this facility. So just making use of that, bringing to our attention, having a peer push for these research activities between campuses is very important. Okay, I don't want to keep going. I will stop here. Any comments, quick question, clarification question, be happy to answer. Otherwise, we go ahead and start with our first session.